All right, so in this video, I'm going to answer questions from my inbox. This is for the summer class, 6 weeks, 2020. Today is August 14th, and we are about to answer these questions one by one. So if you did send me a question, your answer would be here. And if the answer I give does not completely satisfy, make sure to follow up with an email. So the first question I have here says, how do I know which sign my critical value should have? Well, this is all in what kind of tail of test you have. So you could have a left-tailed test, you could have a right-tailed test, you could have a two-tailed test. If you are dealing with a left-tailed test, like in this case, then your critical value will be to the left of the mean. And when we have critical values, they're either z-scores or t-scores. So they're under the standard normal distribution or the t-distribution, and both of those distributions have a mean of 0. So anytime you have a value that's to the left of the mean, that will be negative. So if it's a left-tailed test, you'll have a negative critical value. If it's a right-tailed test, you would have a positive critical value. And if it's a two-tailed test, you'll have both, right? So right now, we have the left-tailed test with an area of alpha equals 0.10 to the left. So if I want to find that critical value, I'm going to go into Excel to do this. And my critical value for a population mean when sigma is known, I will use the z distribution, the standard normal distribution. So that is z equals, and then I'll do norm dot inverse on the left area of 0.1 with a mean of 0 and a standard deviation of 1. And as you can see, I get a negative value. Now, what happens if this was a right-tailed test? Let's look at that. So if it was a right-tailed test, then we would see, let's change this to a right-tailed test. Then we would see the alpha to the right, and I would have a positive critical value. So there's two ways that I can find this value. I can use symmetry and just find the negative one and then change the sign. Or I could look for the left area. The area to the left of this critical value would be 1 minus the 0.10. So all the way to the left here is an area of 0.9. So if I wanted to use norm distribution on the left area, so norm.inv for 0.9 with a mean of 0 and a standard deviation of 1, then I get the positive version of that answer. Now, if it was a two-tailed test, though, the two-tailed test will have half the area in each side, and so that means that you will have a different critical value because the area is different, so it's going to be farther out in the tails since it's a smaller area. So let's go ahead and change this to a two-tailed example. And so with my curve here, I will have 0 in the middle, and then my critical values will be negative and positive, and I will have half of the area, which is half of 0.1 is 0.05. So I'll have half of that area in each tail. So they're going to have the same absolute value, one that's negative and one that's positive. So I can go in here and just do norm.inv on half of the area 0.1 divided by 2 with a mean of 0 and a standard deviation of 1. And then I have to realize that I would need the positive and the negative for that. And in many cases with these questions, you'll be asked to give the positive critical value when it's a two-tailed test. Okay, so I think that question is answered. Let's move on to the next.